So in this lesson we are going to talk about applications of SOHCAHTOA, and to do that we need to first define what's called an angle of elevation and an angle of depression. So if you look right over here in this diagram, you can see that the angle of elevation and an angle of depression are created by a horizontal line, and then this is what we call a line of sight. So the line of sight is basically what kind of draws your attention and what your eye is looking at. So imagine the horizontal. This is like your neutral, you're looking straight ahead, you're looking parallel to the ground. And you see something above you that catches your eye, and you tilt your head up and you're looking up. That's what creates what's called an angle of elevation. So again, it's an angle created by a horizontal line, think your neutral position, and a line of sight to an object above that horizontal line, for example, angle 1. Now the angle of depression is going to be the opposite. So you're still starting with that horizontal neutral line, right? So that's this dotted line. So now put yourself in the position of this pilot. So you're looking straight ahead at the clouds, that's your neutral. And then you notice the tower coming up in the distance. So then you tilt your head down toward this line of sight. Okay? That angle going down from the horizontal is what we call an angle of depression. So the key thing for your angles of elevation and angles of depression is you must always start with a horizontal line. Okay? And then you're either going to go up or you're going to go down. Now one thing to note is, remember, all your horizontal lines are always parallel. So if we have parallel lines, what kind of relationship does angle 1 and angle 2 have? Well, hopefully we all answered their alternate interior angles. And when you have parallel lines with alternate interior angles on a transversal, they are congruent. So what's cool is you can always place an angle of depression at an angle of elevation, and that's usually where I see mistakes. So you can always think angle of elevation, even if you're given angle of depression. So again, that's an important thing to note down, because when we do these word problems in the next few examples, a lot of times it's when you're given the angle of depression, I do see people making mistakes. So if you always want to put angle of depression where you say elevation, perfectly fine, because they're always going to be congruent. Okay, so let's take a look at example 1, and the thing about today's work is you need to not only calculate the missing information, but you need to draw a picture to help you do it. So let's take a look at example 1, and we're dealing with this Space Needle. So we have the Space Needle in Seattle casting a 67-meter shadow. The angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. What is the direct distance from the tip of the shadow to the top of the Space Needle? So we want to be able to interpret what the problem is telling us. And here, our Space Needle, we are going to put as this perpendicular length right to the ground. So there's my Space Needle. Alright, so I'm just going to put Space Needle, SN for Space Needle, okay? And then it's casting a shadow, so where it logically makes sense for a shadow? Well, the shadow should be along the ground. So here's my shadow. And my shadow is 67 meters. We have an angle of elevation going from the tip of the shadow to the top of the Space Needle. So that's telling me my line of sight goes from the end of my shadow to the top of the tower, and that angle is 70 degrees. So there is my picture. What we want to do is we want to calculate the direct distance from the tip of the shadow to the top of the needle. That means directly from the tip of the shadow to the top of the needle. What is that? We're looking for that hypotenuse. So there's x. And once we have our picture, then it's just a matter of what are we going to do, sine, cosine, or tangent, because we're dealing with these right angles, right? So what do you think we're going to do to find x using 70 degrees and the 67 meters? Oops. Well, hopefully we have x is the hypotenuse, and 67 is the adjacent, so the correct work is cosine, because we want to do cosine of 70, which is my angle, is adjacent over hypotenuse. And then we can go ahead and cross multiply and solve. Okay, so there's my solution. Make sure we're rounding to the nearest meter, which is the nearest ones place. Remember, it never hurts to have your exact answer, because on your test, I could ask you to do this on the non-calculated portion, so we want to stop with the exact answer, and of course be able to round it. Alright, let's do one more example, and then we'll finish the last one in class. So let's take a look at example 2. We've got an ice climber standing at the edge of a crevice, and a crevice is basically like a ridge, a cliff, right? That's 115 feet wide. Our angle of depression is what we want to look at now, so we're looking at an angle of depression, not elevation. From the edge from where she stands to the opposite side is 52 degrees. We want to know how deep is this crevice. So, how would we depict this picture? Because we want to be able to create a right triangle out of this so we can do SOHCAHTOA. So, if you think about the ice climber, this is this happy little person, hopefully all bundled up for the cold weather, standing at the edge of some cliff. And it doesn't really matter what that crevice looks like, but we do know that from one end to the other, it is 115 feet wide, right? And then, so here's my opposite side. And we know the angle of depression from where she stands to the bottom of the opposite side is 52 degrees. So that's telling us the line of sight is from the edge, right, where her feet are, to the bottom of the opposite side. So that's my line of sight. So what's tricky here is to remember the angle of depression goes from the horizontal down. A lot of people like to put it here with the vertical, but that's not where it goes. It's going to be the horizontal down. So this is 52 degrees. Remember, if you would like, that angle of depression corresponds to the angle of elevation. So this is also 52 degrees because we have a rectangle, basically, right? Because we can make a right angle, that vertical height of your crevice is going to be perpendicular to the ground here. So then it's kind of up to you what you want to do. So we want to know how deep the crevice is. So the depth is going to be, from top to bottom, that's x. So then we want to look at what we have and think about your SOHCAHTOA. So what do you think we're going to do? Well, hopefully we saw we're looking for the opposite side. We know the 115, which is the adjacent side. So opposite and adjacent should give me tangent. So tangent of 52 equals x over 115. And then we can go ahead and solve that. And there you go, making sure we round to the nearest foot, which is again the nearest ones position, 147 feet. Remember, it never hurts again to have the exact value. Okay, so the examples we did today don't include solving for the angle measure, but I could ask you to find the missing angle of elevation or the missing angle of depression. So make sure you're reading the directions carefully, labeling your diagrams, labeling your diagrams, and thinking about your SOHCAHTOA. So we'll do that last example tomorrow in class. Thanks for listening.